Hello students, during our first online class we looked at number system, and under number system we looked at real numbers, and we said that real numbers, they are numbers. These are numbers both positive and negative, that can be represented on a real number line, e.g. We have the following number line: 0, 1, 2, 3, 4. We have root 2, we have pi, we have 14/3, we have -1, we have -2, we have -3, -4, here we have -1.5, we also have -√10. So real numbers, they are those numbers that include all the numbers, the natural numbers, the whole numbers, the irrational numbers, the rational numbers, except the complex numbers. We also looked at natural numbers, and we said that these are numbers which start. They are numbers which start from 1. They start from 1. That is 1, 2, 3, 4, all the way to infinity. We also looked at whole numbers. We said that these are numbers which start from 0. They start from 0, that is 0, 1, 2, 3, all the way to infinity. Now these natural and whole numbers, they exclude the fractions. Now we looked at integers. We say that these are numbers of the form -4, -3, -1, -2, -1, 0, 1, 2, 3, all the way. They don't include the fractions. Now we have positive. Under integers we have positive integers, and they start from 1, 2, 3, all the way to infinity. We also have negative integers. We start from -1 all the way to infinity. Negative integers start from -1 all the way to infinity. Now 0 is a neutral integer. For this case, the positive and negative integers, they don't include the 0, because the 0 is a neutral integer. That is, it is neither positive nor negative. The positive and the negative integers, they don't include the 0, because 0 is a neutral integer, and hence it is neither positive nor negative. We also looked at rational numbers. We said that these are numbers. These are numbers that can be expressed in the form A over B. That is, they can be expressed as a fraction. They can be expressed as a fraction, where A and B are integers and have no common factors. They have no common factors. That is, rational numbers, they are numbers which can be expressed as a fraction, where the numerator and the denominator are integers and they have no common factors. Therefore, integers, they can be defined as rational numbers whose denominator is 1. We also have terminating and recurring decimals. They are also rational numbers. Now, rational numbers, they are those numbers which can be expressed as a fraction, where the numerator and the denominator are integers and they have no common factor. We also looked at irrational numbers. We said that these are numbers that cannot be expressed as in the form. They cannot be expressed as a fraction. That is, in the form cannot be expressed in the form A over B. For example, we have root 2, root 3, pi, etc. Now, irrational numbers, they are those numbers that cannot be expressed as a fraction. For example, we have root 2, root 3, and pi. These numbers cannot be expressed as a fraction, and therefore they are known as irrational numbers. We looked at a question. In this question, we were prove that root 2 is not a rational number. Or this question can be framed as prove that root 2 is an irrational number. If we are proving that root 2 is not a rational number, then we are proving that it is a rational number. So this question can be phrased as, or prove that root 2 is an irrational number. It is an irrational number. Now, if you are proving that root 2 is not a rational number, then we are proving that root 2 is an irrational number. So, solution. Now, we are proving that root 2 is not a rational number, or root 2 is an irrational number. Now, we prove this by contradiction. That is, we assume that root 2 is a rational number. We first assume that root 2 is a rational number. Remember, we are proving that root 2 is not a rational number. Now, we prove this by contradiction, meaning we are going to prove by the opposite. That is, we assume that root 2 is indeed a rational number. And if it is a rational number, hence we have therefore root 2 can be expressed. If it is a rational number, then it can be expressed as a fraction, where this numerator and the denominator do not have a common factor. Remember the definition of a rational number? Now, this root 2, we are assuming that root 2 is a rational number, and therefore it can be expressed as a fraction where this numerator and the denominator, that is a and b, does not have a common factor. They don't have a common factor. Now we go ahead and check whether indeed this a and b, we go ahead and check whether the numerator and the denominator does not have a common factor. We go ahead and check whether the numerator and the denominator, we check whether the numerator and the denominator have a common factor or they don't have a common factor. How are we going to do that? We are going to name this equation as 1. We are going to multiply the denominator on both sides of equation 1, and this gives us multiply equation 1 with b on both sides, with b on both sides. What do you get? You get b root 2 is equals to a, name that equation as equation 2. Now remember how our equation 2 is. Equation 2 is b root 2 is equals to a. Now you square both sides, of equation 2. Square both sides of equation 2. What do you get? You get 2b squared is equals to a squared, name that as equation 3, since the square of root 2 is 2. Now from this equation 3 we can see that a squared, our numerator a squared is a multiple of 2. You can see from equation 3 we see that the numerator squared, that is, we see that a squared is a multiple of 2, and if it is a multiple of 2, hence it is an even number. Hence it is an even number. From this equation we see that a squared, that is the numerator squared, is a multiple of 2, and if it is a multiple of 2, it is an even number. Now from there we know that the square of even number is even. The square of even number is even. The square of even number is even. Now if the square of even number is even and our a squared is even, hence we have that, therefore we have that a is an even number. Now if a is an even number, this implies that if a is an even number, this implies that a is a multiple of 2. This implies that a is a multiple of 2, and therefore a can be written as, hence a can be written as, remember a is an even number. If it is an even number, it's a multiple of 2, hence a can be written as 2c, name that as equation 4. A is an even number. A squared, we have that a squared is an even number, hence a is an even number, and therefore if a is an even number, it is a multiple of 2. We can randomly write it as this. Now we have come to see that the numerator, which is a, is a multiple of 2. We go ahead and check whether the denominator, which is b, is also a multiple of 2. We check whether the denominator, which is b, is also a multiple of 2. Now, how do you go about that? We are going to substitute this equation 4 into equation 3. We substitute equation 4 into equation 3. Substitute equation 4 into equation 3. So we are going to have 2b squared is equals to, substitute in equation 3, substitute a for 2c. What do you get? 2b squared is equals to 4c squared. Name this as equation 5. Name this one as equation 5. Now divide equation 5. Divide equation 5 by 2. Divide equation 5 by 2 on both sides. What do you get? B squared is equals to 2c squared. Name this as equation 6. We again see that the denominator squared, that is b squared, is a multiple of 2. Hence, b squared is a multiple of 2. We again see that b squared is a multiple of 2, and if it is a multiple of 2, then it is an even number. We again see that b squared is a multiple of 2, and if it is a multiple of 2, it is an even number. Now, if b squared is an even number, then we have that b is also an even number. Then we have that if b squared is an even number, since it is a multiple of 2, then b is also an even number, since the square of even number is even. Therefore, our b, the denominator, is also an even number. Now, if it is an even number, it is a multiple of 2. It is a multiple of 2. Thus, it is a multiple of 2. Thus, it is a multiple of 2. So we have come to see that the denominator, which is b, is a multiple of 2, and the numerator, which is a, is also a multiple of 2. Therefore, they have a common factor, which is 2. Now, thus, we come to find that thus A and B have a common factor. A and B have a common factor, which is 2. Thus, we have come to find that the denominator and the numerator, the numerator, which is A, and the denominator, which is b, they have a common factor, which is 2. And therefore, root 2, if they have a common factor, then root 2 is not a rational number. Thus, root 2 is not a rational number. Thus, root 2 is not a rational number, since the numerator and the denominator, they have a common factor. And we know the definition of a rational number, they should not have, the numerator and the denominator should not have a common factor. And therefore, root 2 is not a rational number. That was the end of our first online class.